Lesson 2.5 is on solving one-step equations. So with this, you're going to have to undo just one thing. So some examples of one-step equations would be like 3 times a number equals 21, or a number divided by 6 is 13, or it could be a number plus -5 equals -28, or maybe 13 equals a number minus -24. So we have problems here with undoing multiplication, undoing division, undoing addition, or undoing subtraction. And notice that typically the variable is on the left-hand side, but it doesn't have to be. The variable can be on the right-hand side. And you can flip them over if you wanted to, but there's really no need to. You can just treat this like it's one side of the equation. And your big goal is going to be to get the n or the a or the n or the n all by itself on one side, and then you'll know what the value of it is. Your goal or your method for solving equations is to get the variable all by itself on one side of the equation. Now, the phrase that you hear teachers use all the time with that is isolate the variable, which means it's isolated, it's all by itself. And to accomplish that, to get number one to happen, you use inverse operations, which are the properties of equality. So if you have, for example, an equation that has an addition in it, let's give a really simple one, a plus 2 equals 3. You would do the opposite of adding 2, which is subtract 2. And whatever you do to one side, you have to do the other. So this would be a 0 pair. That would disappear. It would be worth 0, basically, and a plus 0 is a. And then you would know that 3 minus 2 is 1. So let's look at some examples using all of the operations. Okay, I've got a little bit of a tricky problem. I know it's tricky because it's the third time I've done this slide. So we are doing b plus -16 equals -8. So if we want to use inverse operations, we would have to subtract the same number, -16, and do that to both sides. So over here, this is a little bit tricky. I'm just going to show the work in another space here. For the first operation, -16 minus -16, we're used to writing that in a horizontal form. -16 minus -16. You wouldn't have to do this, but just to make sure we understand how you can do this in this space up here. This would be a keep, change. So keep, change makes this plus +16. So it's plus +16, so that's a 0 pair. That gives us b. Then in this part of the problem, we have -8 minus -16, so we're going to do keep, change. So this would be plus +16. So if we have 8 negatives and 16 positives, that's a net of 8 positives. So to make sure that we have this correct, wherever we go back to the original, which was b plus -16 equals -8. And for b, we put in 8 plus -16, and we make sure this is a true statement, which it would be, because 8 plus -16 is -8, and indeed, -8 equals -8, so that's all good. Our second example is one of undoing a subtraction, and we're subtracting -2, so we'll add -2 to both sides. And this is actually going to turn out to be a little simpler problem than the last one. So here's a 0 pair. It's going to leave a y on the right-hand side, and 13 negatives and 2 more negatives makes 15 negatives. So we go back to the original equation and put in negative 15 minus negative 2 and see if we get negative 13. So this would be, to simplify, this is already done here, simplify this side, we would make it plus positive 2, and hopefully we get a true statement here. 15 negatives and 2 positives makes 13 negatives, so that's good. So that's how we work with subtraction. Next step, multiplication. If you had a problem in your book, I'm going to just review the steps that I want you to do. There are 3 steps. You copy the problem. It's like 5y equals 35. So that's step 1, copy the problem. Step 2, on the same line, when you have a multiplication, you undo multiplication with the division property of equality. And since you're multiplying y by 5, you have to divide by 5 to undo it. Use a division bar. And this would leave you with y. Then you do the multiplication division factor. 35 divided by 5 is 7. Then you come back up and say 5 times 7 equals 35. True or false? It's good. And you know you got the right answer. So you have to copy the problem, use the property of equality, do the arithmetic, and check your answer. You can see division problems written in 2 ways. And let me give you an example. You might see it as a number divided by 6 equals, say, 18. And that's just, you know the answer already probably, but that's fine. If you see a problem like this, if it's written this way, I want you to rewrite it in this form. Use a division bar. The number divided by 6 equals 18, because it's just easier to work with. So if you'd cover up the variable n, you would see divide by 6, and think of the inverse of divide by 6, which is multiply by 6, and you'll see here, this makes it cleaner. Just put 6 in parentheses, both sides. Now, this is a problem that when kids look at it, a lot of times they get wrong. They'll say the answer is 3 because they'll do 18 divided by 6 is 3. But you can see that's not how you're going to get the answer. This a number divided by 6 multiplied by 6 leaves you with the number. So we've isolated the variable. But you don't divide 18 by 6. You actually have to multiply it by 6. And that would give us 108. So then we would just do, you probably just want to, it's kind of bulky to do. Oh, sorry, let me erase that. I would do 108 divided by 6. I can use short division here. 6 goes into 10 one time, remainder 4. 6 goes into 48. 18 times, and that's a good looking answer. So remember, copy down the problem. If you have to convert from the division this division symbol to the bar, do it. Use the property of equality, get the answer, and check your answer. It's really 4 steps. Copy the problem, use the property of equality, do the arithmetic, check your answer.